Okay, let's see. Firearms identification evidence. Through multiple submissions by the parties and 2 evidentiary hearings over the course of 5 days, the trial court ultimately received the testimony of 5 witnesses, one of them twice, 18 reports or articles discussing firearms identification, describing studies testing firearms identification, or criticizing the theory or the results of the studies testing it, and a chart identifying dozens of additional or planned studies or reports. In Section A of this Part 2, we discuss firearms identification evidence generally. In Sections B and C, we review criticisms and studies of the methodology, respectively. And in Section D, we summarize the testimony presented to the trial court. Finally, in Section E, we discuss how some other courts have resolved challenges to the admissibility of firearms identification evidence. Yeah, wonderfully structured, this decision.
Yeah, and I really like, I'm a fanboy of good, well-written appellate decisions, especially ones that are echoing something that I've been preaching for many years, and people have seen me since, I think when I first came on some of these things, I rant and rave whenever there's this testimony coming before a trial that we watch. And I really like subsection E involving the evolving case law, because it's exactly, we're fighting this battle here in Florida, and I'm really hoping that we can piggyback on this case in Florida. And I would say in every state of this union, they should look to this case as the model for how these type of junk sciences are litigated in the courtroom.
Yeah, indeed. In fact, at the federal level as well. So firearms identification is a subset of tool mark identification. A tool mark, literally a mark left by a particular tool, is generated when a hard object, the tool, comes into contact with a relatively softer object, such as the marks that result when the internal parts of a firearm make contact with the brass and lead that comprise ammunition. The marks are then viewable under a comparison microscope, which a firearm examiner uses to compare ammunition test fired from a recovered gun with spent ammunition from a crime scene. As a forensic technique to identify a particular firearm as the source of a particular ammunition component, firearms identification is based on the premise that no 2 firearms will make identical marks on a bullet or cartridge case. That, the theory goes, is because the method of manufacturing firearms results in the interior of each firearm being unique, and therefore making unique imprints on ammunition components fired from it. And again, folks, I would suggest with modern manufacturing techniques in making guns today, those variations are much, much reduced than they might have been 30, 40, 50 years ago. Continuing with the decision, as the United States District Court for the District of Massachusetts explained, now they're quoting from this other court, quote, when a firearm is manufactured, the process of cutting, drilling, grinding, hand filing, and very occasionally hand polishing will leave individual characteristics on the components of the firearm. Although modern manufacturing methods have reduced the amount of handiwork performed on an individual gun, the final step in the production of most firearm parts requires some degree of hand filing, which imparts individual characteristics to the firearm part. This process results in randomly produced patterns of individual stria, or thin grooves or markings being left on firearms parts. These parts are assembled to compose the final firearm. When a round, a single shot of ammunition, is fired from a particular firearm, the various components of the ammunition come into contact with the firearm at very high pressures. As a result, the individual markings in the firearm part are transferred to the ammunition. The ammunition is composed primarily of the bullet and the cartridge case. The bullet is the missile-like The bullet is the missile-like component of the ammunition that is actually projected from the firearm through the barrel toward the target. The cartridge case is the part of the ammunition situated behind the bullet, containing the primer and propellant, the explosive mixture of chemicals that causes the bullet to be projected through the barrel. Close quote. End of the quote from that Massachusetts decision. The patterns and marks left on bullets and cartridge cases are classified into 3 categories. First, class characteristics are common to all bullets and cartridge cases fired from weapons of the make and model that fired the ammunition. Examples of class characteristics include the bullet's weight and caliber, number and width of the lands and grooves in the gun's barrel, that's the rifling, and the twist, the direction clockwise or counterclockwise of the rifling in the barrel. Second, subclass characteristics. And by the way, I don't think anybody has much trouble with class characteristics, but class characteristics are generalized to large numbers of firearms. They're not specific to any single firearm.
Right, and the thing, and that's a good point. And let's talk about what we're not arguing against. We're not saying that a person can identify that this is a 38 caliber shell casing, or that this projectile that's recovered was fired from a 38 caliber firearm. Right,
right, and that is also. That firearm over there, the one we recovered, is a 38 caliber firearm, or is not. So
no
either
problem.
It could have fired the bullet,
or fired from a 308 rifle, and the bullet recovered from the head of the person was a 38 caliber revolver, thus excluding the two. That's good science. That is traditional firearms examination that we on the defense side have no problem with at all.
Right. So the class characteristics are fine, but second, we get to subclass characteristics. Are common to a group of guns within a certain make or model, such as those manufactured at a particular time and place. An example would include imperfections on a rifling tool that imparts similar tool marks on a number of barrels before being modified either through use or refinishing. So these would be now groups of particular guns manufactured at the same place that acquire defects because there were defects in the tools made to manufacture all these groups of guns. So maybe you could tie it to a 38 revolver made at a particular factory in a particular month, for example.
Well, and also I know that I had a case when I was, and they narrowed it down to a high point, which was a high point, I think has a particular reverse type of rifling. So these are what we call class characteristics, which means that it may be within this class based on the fact that only High Point has a particular type of rifling that was found on the projectile. Okay, again, that is not junk science. That is just saying that High Point has this only type of rifling, and this bullet was fired by a rifle or a firearm with that type of rifling. That's a class characteristic, which is admissible, right?
So that's class. We just covered subclass. And now we're doing individual characteristics. Those are unique to an individual firearm that therefore distinguish that firearm from all others. Individual characteristics include random imperfections produced during manufacture or caused by accidental damage. Notably, not all individual characteristics are unique, and individual characteristics can change over the life of a firearm as a result of, for example, wear, polishing, or damage. As will be discussed further below, one dispute between proponents of firearms identification and its detractors is the degree to which firearms examiners can reliably identify the difference between subclass and individual characteristics when performing casework. The Association of Firearm and Tool Mark Examiners Methodology. So this is a formal association of experts, folks, tool mark experts. You think they're going to defend tool mark science? Of course they are. That's why they exist. The leading methodology used by firearms examiners and the methodology employed in this case by Mr. McVeigh is the Association of Firearm and Tool Mark Examiners Theory of Identification, the AFTE theory. Let's see, they reference some other stuff. Examiners employing the AFTE theory follow a two-step process. At step one, the examiner evaluates class characteristics of the unknown and known samples. Again, no problem with that, folks. Let's see, then they have a URL. If the class characteristics do not match, for example, if the samples have different numbers of lands and grooves or a different twist direction, the firearm that produced the known sample is excluded as the source of the unknown sample. If the class characteristics do match, the second step involves a comparative examination utilizing a comparison microscope. At that step, the examiner engages in pattern matching to determine, one, if any marks present are subclass characteristics or individual characteristics, and the level of correspondence of any individual characteristics. This is how they try to get to the unique, the unqualified matching of a round found at the crime scene to the specific gun they have in their possession.